Hello everyone, my name is Tejasva or Tex, and welcome to this video series on how to make a helicopter in Autodesk Fusion 360. So before we get started on this series, I just want to say a big thank you to everyone who supported my aircraft Fusion series on YouTube. In my eyes, it's been relatively successful and I've received a lot of positive feedback, so thank you so much for that. A lot of you recommended me to start my own Patreon page where you can support me financially as well. I am a full-time student, so it does help me out, but I'll talk a little bit more about that later on. If you don't know what that is, the idea is that for a small fee, you get access to a lot more resources than you do for free on YouTube. If that's something you're interested in, I'll be talking a little bit more about that towards the end. Great, so let's get started on the Fusion series itself. Now, similar to my aircraft series, what I aim to do with this series is introduce the mindset of how to actually design a helicopter inside of Fusion 360. There are a couple of reasons why you might want to do this. So you might be an aeronautical engineering student like me, and you're actually designing a helicopter, through which then you would want to model it and run some simulations either through aerodynamics or structural performance, whatever you're doing. So based on that, you would probably need a little bit more detail. If you're doing this for visual or RC purposes, you can pretty much do what I'm doing, follow along, and then build upon that if you really want to. But before we do that, I just want to say I am no expert in helicopters. I have designed aircraft in the past, so fixed wing, but I've not worked a lot with helicopters. I've only designed a few of them and not to a very detailed level. But hopefully the techniques that I will be showing you here can be used as a foundation on top of which you can build your own stuff. Great, so let's talk about the kinds of things you're going to need in order to make this successfully. The first essential thing you're going to need are blueprints. Now, if you don't know what blueprints are basically a three-view drawing, at least a three-view drawing of your model. So in my case, I will be making a Bell 427, just because when you think of a helicopter, this is probably what you think of. So it's a standard sort of fuselage tail configuration. In this case, we've also got a bit of an empennage happening in the back, and we've got a tail rotor and a main rotor, and you've got some skids. So it's a pretty typical configuration for a helicopter, at least in my eyes. So I thought I'd go with this because it's sort of basic, but if you know how to do this, you can obviously build upon it and make more complicated helicopters as well. So in the case of a Bell 427, what you can do is just go to Google, or any helicopter that you're making, go to Google, type in the name of the helicopter you want, and just followed by blueprints. So in my case, I'm writing Bell 427 blueprints, and you'll see a couple of drawings like this. So how do you know which one to pick? In general, the idea is that you want at least 3 views inside your drawing. So this is a great example. This is another great example. And we've also got this one, which is a great example. Now, the level of detail on the blueprints depends on how much detail you want to go into. In my case, I'm sort of doing this as a basic sort of fundamental side of things. So I could really just use this blueprint and be happy with it. However, you'll notice in this one, we don't have any dimensions inside the blueprint. This is another essential thing that I at least like to look for, because what we do with these blueprints is we crop them into the 3 different views, we import them as a canvas inside Fusion 360, and then we calibrate it. And the dimensions really help while calibrating it to scale. So in my opinion, we could either go with this blueprint, so it's got 3 views, it's got some dimensions, and it's also high quality. So in this case, it's 150 by 1292. Another great example would be this one. However, this one has a lot of detail inside it, and we probably don't need these many dimensions. In fact, when we're scaling this, for each view, we only need 1 single dimension. So I think I'm going to go ahead with this one. Okay, so once you've selected your blueprint, what you want to do next is crop them into 3 different images. So in my case, I've got the front view, the top view, and also the side view. And what we want to do is have each of these views as a different image. And the way you want to crop this is such that the top of the blueprint and the bottom of the blueprint touches the edges of the image. And the same thing for the left and right. So over here, you can see that this oval shape, which is representing the circular path that the blades will take, is touching the left and right edge of the image. This doesn't have to be very accurate. It just helps a little bit when you are importing this as a canvas. You don't need to have a fancy software to do this. You can literally go ahead and do this on your phone as well if you really want to. but just try and make sure that this is as compact as possible. You want to repeat the process for your side view and also for your top view. It is not essential that the dimensions that you've chosen are inside the picture, but you always want to make sure that you have the reference image you cropped it from, because we're going to be using this when we import this inside of Fusion 360. Great, so let's head to Fusion. And obviously, the first thing you want to do is make sure that when you right-click on the cube on the top right corner, it's an orthographic view. And the next thing you want to make sure is under document settings, you have the unit type as the one that you want. In my case, my images are in either feet or meters. I'm probably going to go ahead and turn this into meters and press OK. Great, so now all your units will be consistent. I will be making this model in life size, so I'm going to be using those values. If you're making a scaled model, you can go ahead and use the values that you want, but make sure you're consistent. Okay, so the first thing I'm going to do is insert canvas. Okay, and the first one I'm going to import is the side view. So I'm going to double click on the side view. And obviously, because this is the side view, we want it on the side plane. In this case, that's going to be my YZ plane or YZ plane, however you like to pronounce it. And for me, that's the one on the right. So I'm going to arbitrarily scale this right now, and we're going to calibrate it in a second. So just press OK and hit, and now let's go to the right view. Great. So in my case, there are a couple of dimensions that I can work with. So let's go back to our reference image. And when we're looking at the side view, you can see that we have a couple of dimensions to choose from. So the standard one is going from the very bottom of the helicopter, so that's starting from the skids, and the vertical height all the way till the backside, sorry, the top of the helicopter, which happens to be the tail in this case. Alternatively, we could also use from the tip of the nose of the fuselage to the back tip of the tail of the helicopter. For simplicity, what I'm going to do is I'm just going to select the one that goes from the bottom of the skids to the top of the fuselage. And let's see how we can do this. So firstly, I'm going to create a sketch on the same plane. And I'm going to draw a line, firstly, from that point there till that point there. So in this case, we already have a reference line. So I've just drawn another line on top of it, okay? And I'm going to finish sketch here. And what this will allow me to do is have that as a selection and have another white point as a selection, okay? And we know that this value is meant to be 3.49 meters. So what I can do is under canvases, we have imported the side underscore bell 427. I'm going to right click on this and click on calibrate. Okay, now I'm going to zoom in till where I can select that white dot, zoom out and go back to the other white dot. And you can already notice in this case, this is not a vertical line, but that's okay because we're using this as a reference value. In this case, we know that this value is meant to be 3.49 meters. So I'm going to hit 3.49 and click on enter. Now, if I zoom out, you'll see that this should now be scaled correctly. Great. So now the scaling is correct. However, we don't know whether it's in the right position. So I'm going to turn my origin on, and you can see it's sort of located in a very random position right now. I'm going to open my sketch and hide the sketch because I don't need that anymore for now. And I'm going to right click on the side bell 427 and I'm going to click on edit canvas. Then I'm just going to drag this so that the nose of the helicopter is somewhere near the origin of the file. So the origin is your 000. And I want my nose to be touching somewhere over there. Okay. And I'm just going to press OK. So what we've done so far is we've just imported our side view. We've scaled it and we've corrected and we've also positioned it correctly. Now we can go ahead and import the top and the front view. Great. So hopefully you've been able to follow along so far. And as always, if you do have any questions, please do leave them in the comments below. Chances are that if you have a problem, someone else might have a similar problem. So if you leave your doubt in the comments below and I answer to it, it might help other people out as well. Great. So let's continue. So this is the side view, and now let's insert our canvas, insert from computer. And in this case, I am going to import my front view. Okay, and now because this is our front view, we want it to be on the front plane, which in my case is the YX plane. So that's this one right here. And I'm just going to arbitrarily scale it at least till it's in the right magnitude. So maybe somewhere there. And I'm going to press OK. Great. Let's go to the front view. And like before, what I'm going to do is I'm going to draw a sketch on the front plane. And then I'm going to draw a line from here till here. And obviously this is the reference line, and we know that this value is going to be 2.36. Okay, so finish sketch, go back to canvas, right click on the front, calibrate, zoom in till you select the white point, and zoom in till you find the other white point, and there we have it. So we know that this value is going to be 2.36. 2.36, enter. So as expected, it did scale it up, which is exactly what we wanted it to do. And I'm just going to hide the sketch as well because we don't need this one anymore. Okay, so let's zoom out and now let's adjust its position. So hopefully it's now in the correct scale, and we can test out whether it's in the correct scale or not by making sure it's in the correct position and then doing some reference checking. So let's put this up a little bit because we know that we placed the nose of the aircraft on the origin. And so similarly, we want to place the nose of our front view as well on top of the origin. So here, what we can do is on the cube, if you try and select the section that is in between front and right, so that's the edge of the cube right there, it's going to give you an orthographic 45-degree angle. And what you can do here is if you just estimate, so if you look at my mouse right now, and right now I'm hovering over the top of the cockpit, and just draw an imaginary line horizontally right, and that is where the top of the cockpit on the right view should also land up. So currently the front view is a little bit higher, so I'm just going to drag it down a little bit. And now if I just try that again, this doesn't have to be very accurate because when you are 3D modeling it, you can adjust for these things. Okay, now it's too low. So right now it's only allowing me to do 0.60 or 0.70, but I'm going to do 0.65, so I'm just going to manually enter that. And now let me test that again. So I'm just going to draw an imaginary line, and it almost lines up. So I'm happy with this, so I'm just going to go ahead and press OK. So now if I hide the origin again, and if I just do a quick scan, whether the blueprints line up, and they appear to be lined up pretty well. So you can see that even the skids will line up fairly well. So the horizontal line there is almost matching up here. So there's a slight mismatch, but on a bigger scale, it doesn't matter too much. But obviously, if you want, you can take into account and make it more precise if you want to. So naturally, this is only one of the ways of importing blueprints. There are different ways of doing it, and I did mention even in my aircraft tutorial series that there is a more accurate way of doing it. However, the blueprints in this case were not as accurate, so I can't apply that method. But when I make my sports car tutorial, hopefully we can manage to do that over there. So please watch out for that as well if you want. But to be honest, I think this is a really good method as well. And you can always make it more precise according to your needs. Great. So finally, let's just add in our top view as well. So again, now in my case, the top view is going to be on the top plane. And in my case, that is the XZ plane. And obviously, I'm just going to arbitrarily scale it up to the right magnitude first. And you'll often notice that sometimes the blueprint is entered the wrong way. So in my case, the blueprint came the other way around, but that's not really a problem. All you need to do is just hover over this circle here and rotate it by 180 degrees, and you'll be fine. Great, so I'm going to press OK for now. And the reference scale I'm going to be using here is this one. So this is supposed to be 8.24. So as always, I'm just going to create a sketch on the top plane, draw a line from that point till here. So you can see that if I try and draw this line vertically downwards, it's not matching up with that arrow over there. That's okay because we're only using this blueprint as a reference. Later on, if you want to adjust your blueprints, you can obviously go ahead and do that. But for now, I'm just going to follow the blueprint even though it's not fully vertical. And because we're using that as a reference value, I'm going to press enter over there. And once that line is made, finish the sketch and right click on the top view, calibrate, and just make sure we repeat the process there properly. And this is going to be 8.24. So we are expecting it to go up a little bit. There we go. So it scaled it up perfectly fine. And now I'm going to hide the latest sketch. And obviously, hopefully now it's scaled correctly, but we also want it to be in the correct position. So right click on the top view, edit canvas, and move it till the origin. The nose is on the origin. So perhaps somewhere over there. Now you can see that in this case, this is doing relatively well because the line of the symmetry that is on top of the blueprint lines up horizontally as well, which is a good sign. So even though top to bottom, it's not vertically straight, it is a little bit on an inclination, that doesn't matter to us too much as long as the line of symmetry is still correct. Okay, I hope that makes sense. If it doesn't, don't worry about it too much. These are things we are always going to take into account when we do the 3D modeling. Okay, so before I press enter, I want to make sure that it lines up. So when previously we lined it up from the front and right view, now we can line it up from the top and right view and make sure that the noses match up, and they do. And let's go to the back view as well and make sure that relatively they match up, and they do. It almost seems like the empennot section isn't lining up perfectly, but let's see where the problem is. So for now, I'm just going to press OK. Maybe there's a scaling issue, and if there is, there's no need to worry. We can always go ahead and fix this. So this is actually a good thing because since there's a problem here, we can walk through it together. So if you have a similar problem, you can fix it as well. So before we actually try and solve what the problem is, let's think about where the problem could be. Is it a blueprint problem? Is it a scaling problem? Or is it a position problem? So clearly, it doesn't seem like it's a position problem because when I place the nose of the aircraft with the other view's nose of the aircraft, they match up perfectly. For the side and the front view, the heights also match up almost perfectly. However, we still don't know whether the top and the right view match up perfectly or not. So on the nose, they do, but at the back, they don't. So it seems like it's a scaling issue because if you position them relative to each other, they should match up, but they don't. So if they match up in one place but not in another, it's possibly a scaling issue. So let's see how we can fix this. So on the right view, let's go and recalibrate it. So right view is the side view. So I'm going to right click and click on calibrate. And I'm just going to make sure that I entered the right numbers by entering that. And it says 3.51. So it's in the same magnitude, which means we scaled it correctly, at least from this value. Okay. But this also means, let's have a look at the other reference value here, which is the tail rotor. And we see that the tail rotor's diameter should be 1.73. So let's try that out. So I'm going to right click on side view and calibrate again. And I'm just going to make sure it's in the right magnitude. Okay, so it says 1.64 here, whereas it actually should be 1.73. So the problem here we can see is that in the front, we scaled it correctly, so it should have scaled everything else correctly, but it hasn't, which means it's not actually a fusion problem. The problem actually might lie with the blueprint itself. So this is actually not very common, but it's not rare either, that sometimes the blueprints that we get for free from Google can be a little bit non-accurate. So if you are doing this for professional purposes, I would recommend going to professional websites like theblueprints.com, buying a few credits from there, and actually buying a blueprint as well. So that way you can ensure that this entire process that we've done right now is perfectly accurate, and we don't have to arbitrarily scale it left and right differently. So here, because it matches up well with because the side view and the front view match up well, what I'm going to do instead is I'm just going to scale up the side view a little bit so that it matches with the top view, so that when we're making the fuselage, it all looks good. It shouldn't be too much of a problem because we can always guesstimate how this fuselage is going to look like. Obviously, this is a little bit inaccurate. So as I said, if you are doing this for more professional purposes, for simulation purposes, I do recommend buying proper blueprints so that these issues don't come in. But it's actually a good thing that this happened, so I can show you how to solve it. Okay, great. So like I said, I'm just going to scale this up slightly. So I'm going to press calibrate here. And I am going to calibrate this with respect to the back rotor, so 1.73. And edit canvas and make sure that it lines up on the nose. And this looks a lot better than before. However, it's still not in its correct scale. And again, I don't have too much of a problem with this. You'll see why it's not too much of a problem when we start the 3D modeling. But if you are a little bit worried, go ahead and buy the blueprints and then try and do everything that I just did. Follow along, and that should fix all the problems that you've had. So before we end, there's one more thing that I like to do, and that is scatter the blueprints. And this is because right now you can see that there's a lot going on over here. And when we start 3D modeling, we don't want to be having the blueprints as the distractions. So what I like to do is use Fusion's own timeline feature, where we can go back and set a different construction plane as the canvas plane. So I'm going to show you how to do that now. So when you scroll down over here to our timeline, I'm just going to roll back in time before we started anything. And the first thing I'm going to do is click on construct, and I'm going to choose the right plane, and I'm just going to make a plane somewhere over there. It doesn't really matter how far away it is, as long as it's decently far away. Okay, and I'm going to press enter. I'm going to construct another plane from the front and push it back a little bit. I'm going to construct another plane from the top view and push it down a little bit. And you'll see why this is actually really nice. So now I can scroll all the way till the present time. I'm going to right click on the side view, edit canvas, and where it says face, I'm going to select that face over there. So what it's essentially done is it's pushed that back into the right plane, and press OK. And the same thing for the front. So I'm just going to right click on the front, edit canvas, and again, where it says face, I'm going to select that face over there, press OK, and redo that for the top view. So right click, edit canvas, and the face we want to select is the one on the bottom. Great, and now under construction, you can hide the 3 planes because we don't need them anymore. And now you may question, well, why didn't we just do this from the start? Great question. So in my opinion, I like to do them together first and then scatter them, because when we are editing and calibrating the canvas, it's always good to check whether all of them line up properly or not. And in this case, it didn't. And because it didn't, we were able to fix it to some degree and then scatter it. So that's why it's important that we do it this way. So thank you so much, guys, for watching. If you found this useful, please do like, comment, and subscribe. It helps me know that these videos are going great for you and allows me to allocate more time and resources to making these videos for you. If you'd like to step up the support a little bit more, you can follow me on my Patreon page for as little as £1 a month, where you will get access to more resources than what you get for free here on YouTube. This includes personalized feedback on your CAD models, discounts on one-on-one consultations, and also you get voting rights, which means you get to decide what videos come up next on my channel and where to head the channel with. So as little as £1 a month, check out the different tiers available. On top of that, I do make a lot of music, and I'm starting my own podcast soon as well. If that's something that you're interested in, please do follow the links in the description. Here are some links on the screen as well, and I hope to see you guys in the next video. Take care.